Hello guys. Today we are going to see about how the communication it has happened within the switch. That means if there is a switch, I have connected some computers with the switch, how these computers are speaking with each other. Better instead of computers I can use host or system. Why? Because system, host, computers, what it defines in the sense in networking terminology, the devices wherever we can assign the IP addresses or consider as a host and systems. We are not going to connect only the computers with the switches. Even we will try to connect the servers or printers where we can assign IP addresses. So by connecting those servers or printers with the switch, we are going to share the resources to the available end devices. So how the communication is happening locally using the switch, that is what we are going to see today. So this is what the switch I'm going to use now, and I will have some end devices. Okay, I'm going to connect these devices with this switch. Now let's map it some IP addresses. 10.0.0.1 for this, and /8 only I'm going to use. Let's make it simple, and it's going to be 2, it's going to be 3, it's going to be 4, and it's going to be 5. Okay, that's enough. I'm going to give that as an IP address to my systems. Desktop IP configurations. Here it will be 2. Here it will be 3, and here it will be 4. Here it will be 5, and that's it. Yeah, so we're done with the IP configurations. So whenever I'm trying to send some messages from any of these systems, I can able to see my communication goes successful. That means I can able to communicate. And let's see here, from here to here I'm trying to communicate. Again, it's going to be successful. See the source from PC0 to PC1, that is from here to here. Again, let's see here, and I can communicate from here to here, right? That is PC2 to PC3. See here, PC2 to PC3, from source PC2 to destination PC3. So I can able to communicate. I'll show you the ping test also. Let's go to command prompt. Presently I am in the IP of 10.0.0.1, and I'm trying to ping 10.0.0.2 and 3 and 4 and also 5. So I can communicate with everybody. But how this communication is happening? Because as per Cisco and as per the theory, what it says, communication on switch is based on the MAC addresses, right? So how it is learning the MAC addresses and how these peoples are communicating each other, let's go and see that. What I'm going to do, instead of real time, I'm going to switch over to the simulation mode. Now I'm going to start sending the messages from PC4 to PC0. I'm going to start capturing this frames, how it is going to be transmitting. Okay, I'm going to pass it now, and I'm going to capture this ICMP packet. Let's see that the first packet, that is, let's open this. Okay, you can see it is the packet ICMP packet generated at PC4, at devices PC4. Okay, so let's look into that details what it has. In layer 3 it is telling that IP header and source IP is going to be 10.0.0.1, that is its IP address, and the destination IP address is going to be the receiver to whom it is going to send the data or message or information, whatever it may be. So the destination IP is going to be 10.0.0.2. And if you see in layer 2, it is having the source MAC address to destination MAC address. Fine. Okay, and let's go to switch ICMP, and here if you see, the last device is PC4. Presently the ICMP packet is with switch. Now switch, it is not going to do anything with the layer 3 details. It is just going to see at the layer 2 details. Now at layer 2 it is going to learn the MAC address of the PC4. That means the switch is going to learn the MAC address based on the information what it is getting. That means whatever the frames it is coming towards the switch, at the time it is going to start learning the MAC addresses. Here the PC4 is going to send the data to PC0, right? So here my data is going to flow from PC4 to switch, then switch to PC0. When the switch is going to learn the MAC address is a question now. Now PC4 is going to send the frames to the switch 0. Now switch 0 is going to analyze the MAC address detail of PC4, and also it's going to see the destination MAC address. Now it is going to learn PC4 MAC address. That means somebody is sending something to somebody, and who is that sending? From whom I am getting that message? So PC4 is sending that message. Now what is the MAC address of the PC4? This which it's already learned about the PC4 MAC address. Fine. If it doesn't know what is the MAC address of PC4, by this time it is going to store the MAC address of the PC4 in its MAC address table. Fine. Okay, now I am going to play it. Let's see here. Now the last device is switch 0, and presently the ICMP packet is with the PC0, and we can see here. Now we can see the layer 3 details, because switch doesn't deals with anything the layer 3 details. Only our PC is going to see what it is a layer 3. Why? Because he is a destination. Whether he is going to check here really the packet arrives hits for me or not. So it is going to check the destination IP. It is 10.0.0.2. Yeah, it's going to be correct. So now PC0 is going to receive that package, and he will be acknowledging back to the PC4. Now PC0 is acknowledging back to PC4. Now again you will see last device is switch 0, sorry, this one. So last device is PC0 and at device is switch 0. Again you can see only up to the layer 2 device, because this is a layer 2 switch. It doesn't know what it is IP, and it does not see the layer 3 details. It will only look into the layer 2 details, that is a MAC address details. Fine. So this is how they are communicating. Fine. So apart from that, before going to the VLAN configurations, we need to know something called native VLAN in Cisco. So in Cisco devices, native VLAN will be 1. That means we can see inside this switch, enable show VLAN brief is a command. to view the VLAN details on that particular switch. So here I'm having VLAN 1. It is a native VLAN of switch where all the available ports on that switch are mapped with this VLAN number 1. Okay, that is called the native VLAN, and you don't have to worry about these VLANs. These are the reserved VLANs you can see in all the switches as designed by the Cisco. So by default all the ports are mapped with VLAN 1, so that means they are in single local area network. That's what they can able to speak with each other. Apart from this, we are having certain requirements to have this communication possible. Why? Because if you are connecting few systems or hosts to the switch, and if the communication should happen, you need follow some instructions. That means the first instruction, the network ID of all these hosts should be the same, and the host bit of all these devices should not be the same. In this scenario, our network ID is 10.0.0.0. Why? Because my subnet is going to be /8, and the host ID, it will be here 0.0.0.1, and here it will be 0. We can't tell 0. Let's consider it as just 0.0.0.2 only. The remaining 3 octets, it's a host bit, that is 0.0.0.3. Here 0.0.4, it's a host bit, and here 0.0.5 is a host bit. So as per that condition, here I am matching everywhere. My network bit is going to be 10.0. That means the first octet, it is 10. First PC in the first octet of 10, second PC in the first octet is 10, third PC first octet is 10. Like that, all my PCs having the first octet is a 10, and all the PCs having the different host bit. First, this is cancel, just a minute, and the first PC has the host bit of 0.0.1 .1. Yeah, so we can see that all these host bits are different. So what it will be, for example, if I have some other PC, I'll show the demonstration here. Now I'm going to take some other PC here, and I'm going to connect using straight through cable, fast ethernet 0/6 fast ethernet, and I'm going to assign some IP address called 20.0.0.1, which is not from 10 network, it is a 20 network, it is a /8. Okay, let's go and assign the same IP address to the computer. It is 20.0.0.1. Now I'm going to ping 10.0.0.1. Now just a minute, I'm still in the simulation mode. I'll just move this to the real-time mode. I'm going to start pinging now. See here, my message is not, that means my ICMP packets not able to reach the destination. Why? Because they are in the different networks. Not it is for only 10.0.0.1, whatever it is, 10.0.0.2 and 3, whatever you try, it will not happen. Why? Because these PCs are from different networks. So switch is job to provide the communication for the end devices, those who are in the same network. That's what we are calling switch as a local area network device. Switch doesn't know IP protocols, so they don't know how to route the packet from one network to the other network. Its job is only to provide the communication, the devices who are sitting locally and in the same network. Thanks for watching. We'll see you on next videos.